So now we will just move on further. Before I go into the filter design, I just want to remind a few filter terms. Pass band. So pass band means range of signal frequencies that pass through filter. So this is the definition for pass band. And stop band. Stop band means what? Range of frequencies that pass through filter and undergo a relatively strong attenuation. So remember, this is stop band. So let us see here in this ideal frequency response. So here, what is the pass band? For example, in the high pass filter, from here to here, it's called pass band. Selective set of frequency is passing through the filter. And from here to here, it's called a stop band. So that is what I mentioned here in the definition. So this is called a stop band and this is called a pass band. So in all the filters, you have the same. So here, this is the pass band, and this is the stop band. And here, this is the pass band, and this is the stop band. This is stop band. And here you can see this is the stop band and this is the pass band. So these are some terms you should remember when we talk about the filter design. So range of frequencies that pass through the filter and undergo a relatively strong attenuation. So under strong attenuation, that is a stop band. So pass through filter, that is a pass band. Cutoff frequency. So the end of the pass band region. So for the band pass and band reject filters, there are two cutoff frequencies that, so cutoff frequency means that is the end of the pass band region. So again, you can just see this filter frequency response. So this is the cutoff frequency, right? This is the end. And here also, this is the cutoff frequency, it's the end. And here the band pass and band stop, we have two cutoff frequencies. This is the FC1, FC2, FC1, FC2. So this is the definition for cutoff frequency. The cutoff frequency, that is, this is the frequency where the magnitude of the transfer function is 0.707 down from its maximum value. So normally it's like this. V out is equal to 1 divided by square root of V in. That will give you a cutoff frequency when we talk about in terms of magnitude. So for example, here 1 by square root of 2, 1 divided by square root of 2, the value is 0.707. So when we see the frequency response in the later slides, you will understand what does it mean. But right now, just to try to remember the cutoff frequency value, it starts at this level 0.707, or this we can also call this is a minus 3 dB frequency, the gain level. And passive filter means here the filter circuit without amplifier elements, that is called a passive filter. So I also explained this here just before. How can we classify passive filter and active filters? Where is this? Yeah. So passive filter means we are using only R, L, and C to design the filter. The active filter means we are using active components such as transistors, operational amplifiers, together with this RLC. So that is what I mentioned here. So passive filter means filter circuit without amplifier elements or without active elements. And the gain for passive filters is always less than or equal to 1 for all frequencies. So because it does not amplify anything, this is using only the passive elements. So if you apply for example, 1 volt at the input, at the output, you will get maybe 0.9 volt or 0.8 volt. So you will always get the output which is less than the applied input. We are talking about the magnitude. We are not talking about the frequency here. And active filter. Active filter means here filter circuit requires power external to the input signal because it's using the active elements. So these filters can use an amplifier element, for example, operational amplifier. So operational amplifier is one of the active elements. It means op-amp need power supplies. We know that V plus V minus, but it will amplify the signal at the output. So output is always greater than input. So remember here, output is always smaller than the input, but here in the active filter, output is always greater than input. So if you apply the same 1 volt at the input, V in, at the output, maybe you will get 2 volt or 1.5 volt. It's up to the gain, what you are going to have. So this is the V out. So this is an advantage. So these active filters are made by using active elements together with passive elements. So it also gives the selective frequency at the output, but at the same time, it amplifies the magnitude. So that is the difference between active filter and passive filter. So these are some terms. Please try to remember when we talk about the filter design. What is pass band? What is stop band? What is cutoff frequency? And what is passive filter? And what is active filter?